now let's actually work with the function s of t equals negative 16t squared plus 96t. Although we're going to be calculating using our calculator, I just wanted to point your attention to this interactive figure. There are quite a few that come with the book, and this one's not too exciting, but it still gives you a nice visual. The first thing we want to do is we want to find s sub 1 and s sub 0. And so if I just click on the interactive figure, this just gives you a nice visual. You can just get a visual of what's happening with the ball and with respect to the position function. So if I click on 1, it'll give me 1, and it'll also give me s sub 1. So after 1 second, the ball is 80 feet in the air, or the rock, excuse me. After 2 seconds, s sub 2 is our y coordinate, that's 128, so that'd be 128 feet in the air. After 3 seconds, you can see, after 4 seconds, the ball starts to come down. So let's get out of parametric mode and back to function mode to answer the following questions. I want to find s sub 1 and I want to find s sub 0, and we want to explain what these values represent. So my calculator, I go to mode, I'm going to arrow down to function and hit enter, shutting off parametric mode, and then I'm going to hit sequential, shutting off simultaneous mode. And then we'll go to y equals. If you have anything in there, clear it out. And at this point you should type in the function, the negative 16t squared plus 96t. In this case we're going to use x's. So I've typed in my negative 16x squared plus 96x. I also want to set up the window. Now I could play around with the window, but I can see here, just from looking at the graph that is given, that a reasonable window, say on my x, might be, I want to go a little bit farther, I want the full function to show up. So I'm going to go from 0, actually not even 0, it's nice to sometimes be a little bit to the left. So let's say negative 2. So negative 2. And then my x max, I'm going to say about 10. To get the full picture in there. The scale of 1 is fine. My y min, I might keep it negative 20, and my y max 150 looks like that's going to be fine, since it appears that 144 might be the max. The scale of 10 is fine. And let's give it a graph. Let's graph it. So there's our position function that we looked at before. One way of evaluating, if you've already graphed something, is to use the trace key. So if I want to find s sub 1, I hit trace and 1 and hit enter, and it will give me the value. So I know that s sub 1 is 80. So if s sub 1 equals 80, that means that there's an ordered pair 180, and the meaning is that after 1 second the rock is 80 feet in the air. So we can also trace on 0 and hit enter, and we get 0. And so what that means is that after no time has passed, so s sub 0 basically means the initial time and the initial height. So a 0 is the initial time and s sub 0 is the initial height. So initially the ball is basically thrown up from the ground. If s sub 0 equaled 5, that would mean that it was thrown up from an initial height of 5 feet. The next question says find t such that s of t equals 0, and what would be the meaning of s of t? S of t equals 0 means that the height, or the position of the ball, is 0, meaning the height above the ground is 0. We know that happens when t equals 0, so we already have that ordered pair. What we want to find out is when is that going to happen again. So we figure that out by setting the negative 16t squared plus the 96t, we set that equal to 0. Now at this point you could use the quadratic formula to solve this, or you could factor it. And I'm going to factor it. So factoring results, if I factor out a negative 16t, I'll get t minus 6 left in parentheses. So from this factor right here, I know that t equals 0. That's the one we already knew. And then from the t minus 6, I know that t equals 6. So after 6 seconds, the ball has hit the ground again, or the rock. I apologize for keep referring to that as the ball. The rock has hit the ground, and we can go back on our graph and just double check that. Suppose we trace on 6. When we hit enter, we should get 0, and we do. So answering these questions right here didn't involve any calculus at all. This is basically algebra that we're using. And so we now want to move on to the next question. Find the average velocity of the rock between each pair of times given, so over each interval. Another way of writing this would be find the velocity of the rock on the interval from 1 to 3 and on the interval from 1 to 2. And so in order to find the average velocity, and I will use this formula right here, v equals s of t sub 2 minus s of t sub 1 all over t sub 2 minus t sub 1. The subscripts are slightly different from what we used before, but this formula right here works. And we're going to need, we already know s sub 1, but we're going to need s sub 3, and also we're going to need s sub 2. And there's another way, other than tracing on a graph, to evaluate a function using your calculator. And there's a handout that it's posted on the web page that corresponds to this, and it will explain how to do it, but I'll show you right here. As long as your function, the function that you want to evaluate is in y equals, we're going to hit second quit, and we're going to use the vars key, and the vars key is right next to the clear key. I'm going to hit vars, I'm going to arrow over to y vars, and I want to do function, and since my equation is in y1, I'm going to hit enter, and now I just hit open parentheses, and I can do y1 of 2 and hit enter. Now we'll repeat those steps to evaluate the function for 3. So we go to vars, arrow over to y vars, hit enter, enter again, open parentheses 3, close parentheses, hit enter. So we have our two ordered pairs of the values that we need. And just to show you another way, once you've already hit y, you've got y1 of 3, you don't have to use the vars key again to get another value. You can do second enter. So if I hit second enter, that brings back the last expression that I used, and I can arrow back over the 3 and type in another value, even though I already know, I went a little too far there, sorry, even though I already know y1 of 0, it's just to practice that. So you can either do the vars key, or once you've used the vars key, you can hit second enter and return those back. So to use this formula to find the average velocity from 1 second to 3 seconds, I need these two ordered pairs, 180 and 3 144. Plugging into the formula, 144 minus 80 over 3 minus 1 gives us 32 feet per second. Using, for this next part, to find the average velocity from 1 second to 2 seconds, I need the 180 ordered pair and the 2 128 to plug in our velocity formula. Substituting in gives me 128 minus 80 over 2 minus 1, or 48 feet per second. So we found the average velocity from 1 to 3 seconds. We found the average velocity from 1 to 2 seconds. What if I wanted to know the actual velocity at t equals 1 second? Well, this would be the equivalent of finding the average velocity from t equals 1 second to 1 second. But there's a problem with that, because it gives us this formula. It gives us s sub 1 minus s sub 1 all over 1 minus 1, which gives us 0 over 0, which actually doesn't tell us anything. It doesn't say that there isn't an answer, but it doesn't tell us that there is an answer. There's actually a word for this. This is called indeterminate. So what we're going to do, we're going to approach this a little bit differently. Here is where the idea of a limit is going to come into play. We're going to take intervals similar to the 1, 3 and the 1, 2, but just keep making them smaller and smaller. And so we'll start that in the next video.